We'd like to look at another example of computing the definite integral. This is sort of gives us a geometric viewpoint of the definite integral. So in this case we have, and let me turn down the size just a little bit here so that we can see everything. We have the function f of x is equal to x minus 2, so it's a line with slope 1, okay, over 1, up 1, and it crosses the y-axis at -2, and we'd like to calculate the integral from 2 to 7 of f of x dx, or the integral from 2 to 7 of x minus 2 dx. Okay, so we're starting out here at 2, and ending at 7. And what does this definite integral do? Well, it calculates the area under the graph, all right, but above the x-axis over the interval from 2 to 7. Well, let's see, how much area is there? Well, it's the area of this right triangle. All right, so, well, let's see, so how much area is there? Well, this much here is the base of this right triangle is 7 minus 2, that's 5. And since this is at a 45-degree angle, the height is also 5. And so remember that the area of a triangle is 1/2 base times height. So that would be 1/2 5 times 5, which would be 25 halves. So this integral from 2 to 7 of x minus 2 dx is going to be 25 halves. All right, let's take a look at another example. Same function, but I've just changed the limits of integration. This one's going from, all right, from 0 to 5. All right, and notice on this interval, part of the time the graph is below the x-axis, part of the time it's above the x-axis. So remember that whenever the rectangles hung down below the x-axis, that they contributed negative numbers. So because of that, this portion of the graph, all right, or this area down here is going to be treated as a negative, and this one will be treated as a positive. So if I look at this, well, let's see, this rectangle is 2 by 2, so the area, all right, is 1/2 base times height, 1/2 2 times 2. That would be 2, but it'll be treated as a negative number. All right, this rectangle, okay, the base is 3, the height will be the same because it's at a 45-degree angle, so we'll have 1/2 3 times 3, or 9 halves, and so this portion, this area in here, will be a positive 9 halves. I shouldn't say the area, the contribution of the integral. This will be -2, this would be a positive 9 halves. And this will be the value of this definite integral, the integral from 0 to 5 of x minus 2 dx. And so let's see, 9 halves minus 4 halves. Nine halves minus 2 is 5 halves. So the value of this definite integral is 5 halves. And we can think about it as the net area above the x-axis minus the area below the x-axis.